Just this one. Okay, I want us to look at trigonometry. Grade 10, trigonometry is something that is developed from your grade 8. It's also in grade 9. Now we want to create a platform. We want to create a foundation that you are going to be using from your grade 10 right up to your grade 12. This is a very, very important section, and it's used extensively or vastly in the field of engineering. It's a beautiful section. I'm sure you love it. The first section on trigonometry, basically, it is just about naming the sides of a right angled triangle. So I'm going to start by defining what your trigonometry means. All right, trigonometry. Now, trigonometry, at this stage, we are going to be taking it as the study of the relationship between the sides and the angles of a triangle. Basically, we are going to take it like that. Now, we are going to be studying about angles. We are going to be studying about the sides of a triangle. Okay, right. So I'm going to start with what we call a right-angled triangle. Right-angled triangle. What is a right-angled triangle? A right-angled triangle, it is a triangle with one of its interior angles being equal to 90 degrees. Then we call it a right-angled triangle. Okay, right. Now, what are we going to do? I just want us to name the sides of a right-angled triangle. Okay, so allow me to draw a right-angled triangle. Say if you are given something like this, there you go. Remember, one side is supposed to be, one of its interior angles is supposed to be 90 degrees. Okay, there you go. Then you call it a right-angled triangle. This you did in grade 9. Okay, right. Now, let's name our right-angled triangle A, B, C. So we call this triangle A, B, C. Look at the notation, triangle A, B, C. So at B, where the 90 degree, a right angled triangle is not to Pythagoras theorem to calculate the missing sides. And remember, Pythagoras theorem is only used on a right angled triangle. Okay, right. So what I want us to do now is to name the sides of a right angled triangle. How many sides do we have? We've got 3 sides. 1, 2, side 1, side 2, and side 3. Right. I'm going to start by saying, for me to be able to name these sides, the first thing that we are supposed to identify, or the first thing that we are supposed to be given, is what we call the reference angle. Right? So the reference angle, if I come to this vertex and I put theta there, then we are now calling it the reference angle. So what is the importance of the reference angle? The reference angle is going to be it's going to help us identify the sides of the triangle. Okay, let's look at this. The first side, which is very, very simple to identify, is what we call the hypotenuse. The hypotenuse, this is called the hypotenuse. How do I identify the hypotenuse? On my right-angled triangle, the hypotenuse is identified as the longest side. This is the longest side. On your triangle, look at this. This one, from A to C, A to C is the longest side. So we call it the hypotenuse. How else can I identify the hypotenuse from the right angle to triangle? It is the side which is opposite the 90-degree vertex. So if you look at this side, we are now calling it the hypotenuse. Why? It is the longest side. Secondly, it is opposite. It is always opposite that 90-degree vertex. Okay, so this is opposite the hypotenuse is opposite the 90-degree angle. Okay, now let's look at the other sides. Now I've identified my hypotenuse. In this case, AC is the hypotenuse. This is the hypotenuse. Right. Now, from the hypotenuse, I'm going to say, what about AB? Now, if you look at AB, it is the side which is very far from the reference angle. So AB, we call it the opposite. The opposite, it is called the opposite, right? Now, the opposite is always that side which is furthest from the reference angle, right? Now, that which is far away from the reference angle. So if my reference angle is there as theta, now the furthest side is AB. We call it the opposite. So the next side is called the opposite side. Right? Now that's my opposite side. Okay, right. So AB is the opposite. AB is the opposite side. Okay, right. Now we said the side which is furthest from the reference angle. Okay, right. Now we've identified the opposite side. We are left with this third side. The third side there, we call it the adjacent side. Adjacent simply means next to. So we call this the adjacent side. Okay, right. Now we say this is the side next to the reference angle. Next to the reference angle. Okay, right. So in this case, BC is the adjacent side. Okay, right. Now, if you check now, we've got three sides: the hypotenuse, the opposite, and the adjacent side. Now, how do I quickly identify the opposite and the adjacent? Remember, the opposite and the adjacent, they are always relative to the reference angle. if you know, once you identify the reference angle, then you'll be able to identify the opposite and the adjacent. Like in this case, your BC is your adjacent side. Okay, now if the reference angle changes, say you now have another unknown angle, call it beta. Say that angle is now beta. That's your reference angle. If this is my reference angle, it means the side which is furthest from B is now BC. And that which is next to beta is now AB. So what am I saying? The opposite and the adjacent, they always named after the reference angle or relative to the reference angle. If I don't have the reference angle, then I won't be able to identify the opposite and the adjacent. But the hypotenuse is always the same. The hypotenuse does not change. Okay, right. Let's quickly look at an example. Let's quickly look at an example. Example 1. Right. Given the triangle PQR. Right. We've got a triangle PQR below. Right. There you go. I've got my triangle. Right. There you go. Right. There you go. Okay. Now this is going to be your 90 degrees. Right. Call this one P, Q, then R. Okay. Right. P, Q, R. Now, if my reference angle is theta there, if theta is the reference angle, if theta is the reference angle, name the sides of the triangle. Name the sides of the triangle PQR. Okay, very simple. Now, look at this. This is my reference angle, right? Since this is my reference angle, it means that is going to be my my opposite side. And from the opposite side, this is the side, the furthest side from the reference angle. And this one, PQ, is the one, the adjacent side. This is the adjacent side, right? The opposite and the adjacent, PQ, they always meet at 90 degrees. Opposite and adjacent, they always meet at 90 degrees. And the hypotenuse, the longest side, is always opposite the 90-degree vertex. So this is the hypotenuse. Okay, now that's my hypotenuse. If you look at the hypotenuse, you realize that the hypotenuse connects the opposite and the adjacent. Hence, you get line PQ. So I'll come and say P R is the hypotenuse, right? Then PQ is the adjacent, the one next to the reference angle. Then QR is the opposite, the one furthest from the reference angle. Okay, so this is the opposite side, and that is the adjacent side. Okay, now this is how you name the sides of the right-angled triangle. Okay, right. I'm going to quickly give you another example. But before that, what one should also know is once the reference angle change, if I've got something like this and we are calling it alpha, remember unknown angles at this stage, you can use theta, you can use alpha, you can use beta. Now, if R, where alpha is your reference angle, it means the side which is now furthest from the reference angle becomes PQ, and the adjacent becomes QR. Now, what you should then know is QR and PQ, they are meeting at 90 degrees. Always the opposite and the adjacent, they meet at 90 degrees, right? And opposite and adjacent, they change. Once you change the reference angle, it means their position is also going to change. But the hypotenuse does not change. The hypotenuse stays the same. Okay, all right, let's look at example number 2. Okay, on your example number 2, I've got a right angle triangle here. Right. On example number 2. Okay. Given triangle ABC. Given triangle ABC. Right. Let me draw your triangle ABC. That's your right angled triangle. That's your right angled triangle. Right. This is A, that's B, that is C. Right. Our question is name the sides of triangle ABC. Right. Now, my reference angle, call it alpha. That's where our reference angle is. Remember, you cannot name the sides of a right angled triangle before identifying the reference angle. So my reference angle is alpha. Okay. Now, once that is the reference angle, first I can see that AC is the hypotenuse. Right. This side, it is the hypotenuse. Remember, the hypotenuse is always opposite to the 90-degree vertex. Okay, right. Now from there, if this alpha is the reference angle, it means AB is the opposite side. So I can come and say AB is the opposite. It is the opposite side. Okay, now from there, BC, it is the side which is next to the reference angle. So I can come and say BC is the adjacent. It is the adjacent side. Okay, right. Now, those are the 3 sides that makes this right angled triangle with alpha as your reference angle. Okay, right. That's about it, I'm going to give you an activity where you are just naming and identifying the opposite, the hypotenuse, and the adjacent of any right-angled triangle which is drawn. Thank you.